Hello and welcome. Today we are going to look at electrolysis, and in particular we're going to look at the electrolysis of ionic compounds so that we can break them down into the different elements that might be present. So the example we're going to use today is a substance called lead bromide, and that is going to be our electrolyte. So an electrolyte is a substance that we carry out electrolysis on, and lead bromide is an ionic compound, but before we can carry out electrolysis we have to heat it so that we can melt the lead bromide. So if we apply some heat, this will melt the lead bromide, and that's important because when we melt it, it breaks it down into the two ions that are present in the compound. In this case it's lead, which is Pb, with a charge of 2 plus, and bromide is Br with a charge of a single minus. Okay, so when we break this down by heating, or sorry, when we melt the lead bromide, what we have is the two ions separated from each other because the energy from the heat will separate those two out. Now what we can do is actually look at what's going on in this area here at the electrodes a little bit more closely. So if we have a slightly closer look, here we said we've got the electrodes. That's an important keyword. The positive one is called the anode, but it's also called the positive electrode, and the negative one called the negative electrode, or also called the cathode. Now inside the electrolyte here we have the ions that are free to move because the compound has been melted, and we can see that if we start off with the negative electrode, we've got positive lead ions there, and because they have a positive charge they will be attracted to the negative electrode. So we have our lead ions collecting at the negative electrode because positive attracts negative, but that's not the end of the story. What we actually have is the lead metal actually being produced here, and it will coat this electrode here. But before we can do that, these lead ions have to turn into lead atoms. Now the way we do that is we have to add electrons. Now electricity is the flow of electrons, so as the electricity flows, or the electrons flow, they provide the electrons that can be used to balance out these ions and make them into atoms. So this ion here has collected two electrons and balanced out the ion and made it into an atom. So what actually happens at the negative electrode is this: the lead ions combine with electrons to produce the lead atom. In actual fact, it will then produce lead metal on this electrode. And conversely, on the positive side, on the positive electrode, we have the bromide ions which are attracted. So they'll be attracted to the positive electrode, but they don't gain electrons over here. What they will do is actually they will lose one of their electrons, because to become an atom they currently have a negative, one extra electron, so they'll lose that electron, which will then flow off into the circuit. Okay, so then we end up with the atom of bromine. So we have bromide ions, we call this bromide when it's an ion. They lose electrons, each one will lose one electron, it will become the bromine, the element bromine, or bromine atoms. Okay, when it's as a ion we call it bromide, when it's as the atom or the element we call it bromine. Okay, so this is what's happening at each of the electrodes. Now there's one more key phrase, or a couple more key phrases that you need to be able to use when talking about this. When we have our lead combining with electrons, what we say is that it's gained electrons, and when an ion gains electrons we say it has been reduced. That's the key word there, reduced. So lead has been reduced because it's gained electrons, and with bromine it loses electrons, so we say it has been oxidized. Okay, so those two key words are important. A good way to remember that is this word here, oil rig. And when we're talking about electrons, oxidation is loss, reduction is gain. So the lead ions have gained electrons, so reduction is gain, so we say they've been reduced, and the bromide ions have lost electrons, so we say they have been oxidized because oxidation is loss. So it's quite a useful little term there to use to help you remember that. Now the next thing I want to cover just very briefly is that we don't necessarily always need to melt compounds in order to carry out electrolysis. With something like sodium chloride, we can dissolve it in water, so we end up with sodium chloride solution. Now, the slight problem there is that we don't have just the sodium and the chloride ions moving around in the solution. We also have hydrogen ions and hydroxide ions, and these two, hydrogen and hydroxide, come from the water. So we have 4 ions moving around. Now, the positive ions, the hydrogen and the sodium, might get attracted to the negative electrode, but what you've got to remember is they won't both be produced there as elements. The element that is produced depends on how reactive the ions are, or how reactive the ions are of the element that we're talking about. So the more reactive out of these two is sodium. So sodium will stay in solution. It won't actually collect and be produced at this negative electrode, but hydrogen will, because hydrogen is less reactive, so that's the one that's going to come off and be produced. So here we have hydrogen ions. They gain electrons, and you'll remember from the last slide, reduction is gain, so they become reduced and become hydrogen atoms. Okay, in actual fact, it will become hydrogen gas, which exists as H2, or 2 atoms joined together. Okay, so that's a key point about compounds in solution. And the next thing I want to look at here is just a little use of electrolysis, and that's called electroplating. And electroplating is used to cover a metal with another metal in order to make it either more attractive, or to give it a layer of protection, or even to make cheap jewelry. So you can cover one metal with another metal and just plate it and make some cheap jewelry, rather than having the pure metal as the jewelry itself. Now, the way this works is very similar. We've got a spoon here that's made out of metal. We can use silver nitrate, and silver nitrate can be broken down as the ions, and the silver will have a plus charge, and that will then be attracted to the spoon, and it will coat the spoon with a layer of silver. So that's one use of electrolysis in electroplating. Other types of electroplating you could do are copper electroplating, or copper plating. You can do nickel or chromium, but all the uses are very similar, either for protection or to actually improve the appearance of the metal that you're using. Okay, now the last thing I want to go through quickly is this idea of half equations, and this actually is part of the higher tier. And half equations are equations that describe what's going on at the 2 electrodes. Now, this is the example that we used previously, so let's stick with that. Lead bromide, we have at the negative electrode, and we've looked at this before, so we know what's going on, but let's have a look at the half equation. We've got lead, which has a charge of 2 plus. That gains electrons, so we say plus electrons. Electrons is written with a E with a small minus, and that will give us lead metal. But what you might realize is that we've got a charge of 2 plus here, so 1 electron is not going to be enough, so we need to balance this half equation, and it's actually very straightforward. We've got 2 plus here, 1 minus, so we just put another, or we put a 2 in front of the electron, so that we know we've got 2 electrons that are required to balance out the charge and therefore make the atom. At the positive electrode we have bromide, and these have a negative charge, so what we do is we subtract an electron, and that gives us bromine gas. Now, the slight issue here is that bromine gas exists as pairs of atoms like that, so we have Br2, so again this is unbalanced, so we have to balance it, and in actual fact it's quite straightforward. All we do is we have 2 bromide ions reacting with 2 electrons to make our Br2. So these are 2 half equations representing what's going on in the electrolysis of lead bromide. Actually, it's worth mentioning here that we have another way of writing what goes on at the positive electrode and what happens with the negative ions here. Instead of writing Br minus 2 electrons, we can write it the other way around, where we have bromide minus, but that goes to an arrow, gives us bromine gas plus electrons. So remember we said it was 2 there and 2 there. So you can actually write it out the other way around with the arrow at this end of it here. Now it's probably worth practicing a couple of these. So here are a couple of examples, 5 examples, and it might be worth pausing here, you having a go yourself at balancing these half equations and then seeing what you come up with. I'll go through the answers when you finish. So if you pause now, give it a go, and then you can go through the answers. Right, so for the first one here, this is what's happening at the positive electrode. We have chloride ions becoming chlorine gas and some electrons, quite straightforward, Cl2, so we need 2 of those and 2 of those. For this equation here, this is happening at the negative electrode. We've got calcium with a charge of 2+, so to make the calcium atom we need 2 electrons, so that will balance that out. For this one we have hydrogen, which becomes H2 gas, so we need 2 of those and 2 of those. Aluminium becomes aluminium, the aluminium atom, so we've got Al3+, so we need 3 electrons. And for the last one, probably the trickiest one, but we've got oxygen, which has a charge of 2-, becomes O2, the gas, plus electrons. So we've got 2 ions with a charge of -2, so we need 4 electrons in order to balance this equation here. Okay, so there's a few examples of what you might have to do. This has been slightly longer than I expected it to be, but all important stuff. So thanks for watching, and I'll see you again soon.